Most people can name the planets within our solar system, from Mercury, the closest to the Sun, to Pluto, the farthest and arguably not even a planet. When discussing potential for extraterrestrial life, most people think of Mars. They might be surprised to hear that further down the street, at the colder end of our solar system, are a few moons that are just as interesting, if not more interesting, than Mars. Enceladus is the sixth largest moon of Saturn, but is still only 500 kilometers in diameter. This tiny moon is one of the brightest objects in the solar system, reflecting 100% of the light that hits it, in comparison to the mere 11% reflected by Earth's moon. Enceladus's reflectivity told scientists that the surface was covered in very clean ice, and that it therefore had to be very young. If the moon were older, its pristine surface would have collected debris and appeared discolored. Up until 2005, this was the most that scientists knew about Enceladus. The Voyager probe had passed by the moon twice already, once in 1981 and again in 1982, but had done so at a great distance and hadn't viewed Enceladus at a very good angle. 23 years later, the much more advanced Cassini probe flew through the Saturn system and gave scientists on Earth the best look they had ever had at Enceladus. Cassini imaging from January of 2005 to April of 2012 revealed a surface covered with large boulders of ice and cracks in the moon's surface. The south pole of Enceladus showed a very distinct cracking pattern, referred to by scientists as tiger stripes. But perhaps the most surprising discovery made by the Cassini probe was the observation of plumes of liquid spraying out from the cracks in the planet's surface. The jets were contained within the south polar terrain, suggesting that there could be liquid water beneath the crust in this area. For the next 7 years, Cassini passed by Enceladus at different speeds and distances, collecting images of the moon and samples of the plume vapor itself. Using the image data to track the moon through its orbit, scientists noticed something strange about the way that Enceladus rotated. Enceladus' odd shape and distribution of mass causes the planet to experience instances of high torque. These instances of torque were observed in the form of physical librations, or oscillations, of the planet's surface. In layman's terms, the surface of Enceladus wobbled as it rotated. Cassini scientists were able to measure this wobble by tracking physical landmarks on Enceladus' surface through the many images taken by the probe. They then developed and applied a series of models to figure out what was causing this wobble. The only model that fit the data was one that gave Enceladus not a small lens of water at its south pole, but a global subsurface ocean. The model suggested that the surface of Enceladus was only a layer of ice floating atop the ocean, and that the tiger stripes were the result of periodic torque events causing the ice layer to crack and split. This meshed well with the fact that the samples Cassini had collected of the plumes themselves had been salty, suggesting that they originated from water that was stable and in contact with a mineral layer, rather than the result of fleeting ice melt. The plumes themselves were most likely limited to the southern polar terrain because the surface ice appeared to be thinnest in that region. At the time of this video, amino acids have yet to be directly detected on Enceladus. However, there is every indication that the ocean on Enceladus is habitable and that the icy particles in the plume are samples of that habitable water, according to scientists at NASA's Ames Research Center. It is important to note that although it is surprising to find liquid water so far away from the heat of the sun, it is not as impossible as it seems. As with other ice-covered satellites, Enceladus is heated from the inside out. Silica particles in the E-ring of Saturn have been traced back to Enceladus's plumes, suggesting that its ocean floor may be hydrothermally active. Besides this is the phenomenon of tidal dissipation, also known as tidal heating. As a planet or moon orbits, especially if it orbits non-synchronously, where the orbit of a satellite is not equal to the rotational period of the body it is orbiting, meaning that it takes a satellite a different amount of time to move around its planet once than it does for that planet to rotate once. It experiences changes in its gravitational potential that do work on its oceans or interior. The gravitational forces are often the result of other celestial bodies, such as nearby planets, forcing the satellite into a non-circular orbit. The changing potential energy flexes the ocean and leads to the generation of thermal energy through friction. An important influence on tidal dissipation is bottom drag, wherein the interaction of flowing liquid with an uneven ocean floor generates turbulence and potentially decreases the momentum of the flow. Scientists at the University of Arizona modeled the effects of bottom drag on tidal dissipation on Enceladus and Titan, another moon with significant bodies of water. According to their calculations, heating or dissipation due to bottom drag generally decreases with increasing ocean thickness, with periodic spiking at certain depths. However, the modeled depths at which any of these forces caused significant tidal dissipation is much shallower than the estimated depth of Enceladus' ocean. Therefore, tidal dissipation alone is not enough to provide the heat necessary to keep Enceladus' ocean in liquid form. Another paper published a year later has suggested that the moon's core may be made of extremely porous rock, allowing the previously mentioned tidal forces to drive water through it, and thus generate enough friction to heat the ocean and drive hydrothermal activity. Enceladus may not be as well known as the planets in our solar system, given that it is only one out of a massive and rapidly expanding pool of moons, currently up to 82. However, its unique characteristics make it a fascinating object of study for astrobiologists. In fact, Enceladus is so interesting that there was a significant debate over which moon should be the next to have a dedicated mission: Enceladus or Europa, another very interesting moon of Jupiter. Nevertheless, it is clear that this tiny moon is hiding some big secrets. Whenever it is that we can get back to study Enceladus, we hope that it will share some of them with us.